Hello everyone, I'm Rajasri, Assistant Professor, Department of Electrical and Electronics Engineering, working at MLR Institute of Technology, Hyderabad. And in today's lecture, I'll be discussing single-phase fully controlled rectifier with RL load with freewheeling diode. And here is a circuit diagram of single-phase fully controlled rectifier with RL load with freewheeling diode. And if you see, here we have four thyristors, namely T1, T2, T3, T4. Along with that, we have a freewheeling diode over here, which is connected across the load, across the RL load. And what is the reason why we are connecting a freewheeling diode over here? It is because in order to eliminate the negative spike, we usually make use of freewheeling diode. And if at all, if we can eliminate this negative spike, the power factor can also be improved and we can obtain the continuous current conduction through the load. So that is the idea behind. These are the various advantages associated making use of a freewheeling diode. And here, the basic purpose of a rectifier, it converts AC to DC. And here the input voltage is alternating in nature, which has got both positive half cycle as well as negative half cycle. And when the positive half cycle is appearing across the load, at that instant the polarities will be positive, negative. And because of such kind of polarities, see, anode of the thyristor 1 is positive with respect to cathode, such that T1 is forward biased, as well as because of the negative polarity, cathode of T2 is more negative with respect to anode. T2 is also in the forward blocking state. Now, T1 and T2 are in the forward blocking state. That means it is ready to conduct but not at conducting state. At this instant, if we can provide the triggering pulse, at that instant T1 and T2 starts conducting a current through the load. So here, during the positive half cycle, we can provide a triggering pulse for thyristor 1 as well as thyristor 2, such that the output voltage starts conducting right from this alpha. It is forward bias right from 0, but the moment when we provide triggering pulse itself, thyristor starts conducting, that is from alpha to pi. Alpha to pi, thyristor 1 and 2 is conducting a current through the load. Let us check out this, the same thing, even in the individual circuit diagram during the positive half cycle. If you see, during which thyristor 1 is short circuited since it is turned on, as well as thyristor 2 is short circuited, whereas T3 and T4, since these two are in reverse bias state, these acts as off switches. So the moment when we provide triggering pulse, T1 starts conducting current through the load in this direction. Say this is A and B. This is the direction of current flow, and through T2 and back to supply. This is how the current flow path during the positive half cycle of the circuit, and the current flow through the load will be in this direction. And what is the voltage which we are actually feeding as input, that is Vs, output voltage is equal to output voltage will be V0 is equal to Vs. Whatever the voltage which we are feeding will be appeared across the load. That is how we get V0 is equal to Vs. And if you see, here we have an inductor. Initially, when the current flow is started flowing through the load, inductor starts charging with certain polarities, positive and negative. And the moment it reaches pi, actually what happens is, see, if you observe during this polarity, this positive is applied across the cathode of the freewheeling diode and this negative is applied across the anode of the freewheeling diode. That is how this freewheeling diode acts as open circuit. That is, it is reverse bias and it acts as open circuit and it does not allow any current through it. And the moment when it reaches pi, negative half cycle has been appeared, and because of which the polarities across the circuit will be, supply polarities will be negative, positive, negative, positive. And during which, since anode, if you see, inductor was charging previously with such polarities like positive, negative, and now the polarities, by the time the inductor is completely charged during this process from alpha to pi, at this instant called pi, the inductor reverses its polarities as negative, positive, in order, and in this process, what happens? This positive is applied across the anode of the diode such that now freewheeling diode is forward biased and it acts as short circuit. So whatever the energy stored in the inductor will be driving that energy will be driving the current through the load, through the freewheeling diode, since freewheeling diode is completing the path, and that is how the current is actually flowing through the load. There is a continuity of the current flow through the load, and we are getting the output voltage. So that is the reason here thyristor 1 and 2 will be turned off, and during this instant freewheeling diode is actually conducting. So what? We don't get negative spike, and again from this instant during negative half cycle, since polarities are negative and positive, T3 will be forward bias as well as T4 will be forward bias, whereas T1 and T2 are turned off since these are reverse biased during the negative half cycle, and T3 and T4 is conducting the current through the load from A to B. This is the output current, and across which we get the output voltage, which is equal to Vs. So during the negative half cycle, T3 and T4 is conducting the current through the load. And if you see at this instant called pi plus alpha, we are providing the triggering pulse for the thyristor 3 and 4 such that thyristor 3 and 4 is conducting a current through the load right from this instant called pi plus alpha to 2 pi. And again here at this instant called 2 pi, again freewheeling diode comes into the picture, and here we are getting the output voltage due to T3 and T4, and again at this instant called 2 pi plus alpha, T1 and T2 are conducting the current. Cycle repeats. So this is what the output voltage is, and now let us check out the output current waveforms. The current through the load. So at this instant, see, at this instant called alpha, we have provided the triggering pulse such that thyristor 1 and 2 is conducting current through the load, and due to the presence of inductor which does not allow any sudden changes in the current, so what? Current through the inductor is building at a slow rate. Current through the load is building at a slow rate, and it is becoming maximum at this instant called pi, and later whatever the energy stored in the inductor is driving the current through the freewheeling diode. That is how we are getting the output current through the load during this instant when freewheeling diode is conducting, and that is how there is a continuity of the current flow through the load. And when freewheeling diode is conducting, T1 and T2 are getting turned off at this instant called pi. And again, when it reaches pi plus alpha, what happened? Whatever the energy stored in the inductor, it is completely driving the current through the load, and in this process whatever the energy stored in the inductor is completely dissipated. So what? The energy stored in the inductor becomes almost zero, and it is turning off the freewheeling diode at this instant called pi plus alpha. And this moment when it reaches pi plus alpha, since we are providing the triggering pulse for already forward biased T3 and T4, so what? Current is building at a slow rate and becoming maximum at this instant called 2 pi, and again freewheeling diode comes into picture, thereby it is driving the current through the load, and thereby continuity of the current flow is actually maintained. And here I am connecting it to the back end. So this is what our output current waveform is. And now let us see the output that is voltage across the thyristor 1 as well as voltage across the thyristor 2. Voltage waveform of thyristor 1 and 2, that is only appeared during the off state of the thyristor 1 and 2. So thyristor 1 and 2, it is not conducting from 0 to alpha. Thereby, the voltage across the thyristor 1 and 2 will be just similar to that of the supply voltage. And again, since it has come into the conduction state, T1 and T2 has come into the conduction state at this instant called alpha. So what? Here voltage is becoming 0 and it is remained 0 till this instant called pi. And again at this moment, pi to pi plus alpha, pi to 2 pi, pi to 2 pi, and again it is off from 2 pi to 2 pi plus alpha. So this is what your output voltage waveform across the thyristor 1 and 2. Voltage waveform across the thyristor 1 and 2. Again, we will have to derive the expression for average output voltage. So what? V naught average is equal to, I am writing directly, 1 by time period. Here time period is every similar cycle is repeating for pi, and actual waveform is present from alpha to pi. So the limits are, it is conducting from 1 by pi, conducting from alpha to pi, Vm sin omega t d omega t, and here Vm by pi, constant bringing it out, integration of sin omega t is minus cos omega t, conducting within the limits alpha to pi, Vm by pi, substituting the limits, upper limit minus lower limit, minus cos pi, minus of minus plus cos alpha, cos pi is, value is minus 1, minus of minus plus 1, 1 plus cos alpha. This is a V naught average expression. And if you see the V naught RMS expression, I am not taking the general formula. Total time period is 1 by pi, conducting from alpha to pi, Vm square sin square omega t d omega t whole to the power of 1 by 2, Vm square, bringing it out, Vm square by pi, and in order to integrate sin square, I am writing this in terms of 1 minus cos 2 omega t by 2 within the limits alpha to pi, and bringing this 2 out, Vm square by 2 pi, and integration of 1 is omega t, conducting from alpha to pi, minus integration of cos 2 omega t is sin 2 omega t by 2 alpha to pi whole to the power of 1 by 2, and here Vm square by 2 pi, upper limit minus lower limit, pi minus alpha, minus sin 2 pi by 2, minus of minus plus sin 2 alpha by 2 whole to the power of 1 by 2. Since this term is 0, we get, applying 1 by 2 here, Vm by root 2 pi inside pi minus alpha minus 0 plus sin 2 alpha by 2 whole to the power of 1 by 2. This is a V naught RMS expression for single phase fully controlled rectifier with RL with freewheeling diode. And coming to the peak inverse voltage, this is the maximum negative voltage which is applied across the thyristor during the off condition. So peak inverse voltage is equal to V maximum. And if you see the circuit turn off time, for how much time period the thyristor is turned off, that is circuit turn off time is equal to pi by omega. In the coming up lecture, we will be seeing single phase half controlled rectifier with RLE load. Thank you.